How are you, my friends? This is lecture number 27 of the pre-calculus course, Vectors in 2 Dimensions. For the objectives here, we will look at the geometric description of vectors, vectors in the coordinate plane, and some other questions. What is a vector, guys? A vector is a directed line segment. So from A to B, we can say vector AB, or we can say vector U, or we can give it any letter we like. Two vectors are equal or equivalent if they have the same magnitude and the same direction angle. So in every vector, we have to look at the magnitude, which means the length, magnitude of the vector, and the direction angle. Equal vectors need not coincide. They must be parallel or in the same direction. So here we see vectors U and V are equal. See here. Vectors E and F are not equal because they have different magnitude. And vectors C and D are in the opposite direction, so they are not equal. We can multiply a vector by a number. We call it scalar. Scalar means just a real number. K can be multiplied by a vector. So if we have a vector U, we can say 2U, we can say half U. See, this is the same direction because K is positive. If K is negative, it will be in the opposite direction. We can write a vector in the corner brackets like AB. See, this is corner brackets. We call it vector U here. See, from the origin 0, 0 to AB, that's a point AB. Then the vector, we call it U. So this is the initial point. And we call this the position vector. Direction angle, this is theta here, from 0 to 2 pi. It's the smallest positive angle in standard position formed by the positive x and the vector itself. So it can be in quadrant 1, it can be in quadrant 2, it can be in quadrant 3, it can be in quadrant 4, between 0 and 2 pi. Component form of a vector. If we have the initial point not on the origin, so we have like from P to Q, that's a vector here. So this point here, x1, y1, that's point P, we call it initial point. And this one is the terminal point Q, x2, y2. So we can find a vector PQ from P to Q. We can call it V or PQ. It will be x2 minus x1, and then y2 minus y1. Now let's look at example 1. Find the component form of the vector AB with initial point A and terminal point B. So A here is x1, y1, and B is x2, y2. That's so easy. So the desired vector is AB. See, it said here, find the vector AB from A to B. So x2 minus x1, which means 3 minus minus 2, y2 minus y1 is 7 minus 5. So the vector will be 5 and 2. Given the vector V, 3, 7, with initial point 2, 4, what is its terminal point? So like we start from the vector 2, 4, we have to reach another point, the terminal point, and we have the vector between them is V, 3, 7. So what can we do here? We say given the vector V, 3 and 7, and the initial point is 2, 4, now let the terminal point be xy. Now, V, we have 3 and 7, and the terminal point is xy, but the formula is x2 minus x1, y2 minus y1. So it will be this x minus the 2, y minus the 4. So we can make an equation here. We take the x component, 3 is equal to x minus 2, and the y component, 7, is y minus 4. Then x will be 5, and y will be 11. So the terminal point is 5, 11. Now the magnitude formula is very important, and the direction angle of a vector. So we can apply here the Pythagorean theorem. We have a vector from the origin to AB. So this is A and this is B. If we need the magnitude, the length, we say mag or magnitude of the vector. So we put 2 bars there. It's not absolute value. We put 2 bars and then U, which means the magnitude of the vector. So it will be square root of A squared plus B squared. Easy, nice formula. And then we have to find the theta, which we call it the direction angle. Now, theta, the direction angle, satisfies, if you here find tan theta will be the opposite over the adjacent. So tan theta will be B over A. But you have to be careful where the vector lies. If the vector is in quadrant 1, quadrant 2 maybe, quadrant 3, quadrant 4, so the tan theta can be positive or negative according to location of the vector. We will see some examples. Okay, let's see here some example. Given the vector u, 2 minus 2, find the magnitude and the direction angle of the given vector. So let's go by the formula, so easy. The magnitude here of the u is the square root of a squared plus b squared. So which is 2 squared plus minus 2 also squared. So that's square root of 8, which is 2 square root of 2, positive number always. That's the magnitude. Now we see the x here is positive and the y is negative. So it lies, the vector, in quadrant 4. Now let's say tan of theta, b over a, which is minus 2 over 2, which is minus 1. So from this, we can find the reference angle. Tan theta is 1. That means the reference angle is pi over 4. And this minus means it is in quadrant 4 because of the plus and minus, because it can be minus plus sometimes. It will be in quadrant 2. So the direction angle now, remember the reference, 2 pi, which is in quadrant 4, minus the reference angle, pi over 4, which will be 7 pi over 4. This is the direction angle of the vector u. Now there are two other definitions. We call them horizontal and vertical component of the vector. Horizontal, see, it's so easy. From the word you can see horizontal, that's the A. See the horizontal, this is horizontal component. Just remember the name, please. Vertical component is the B itself. So A and B can be positive or negative. Now, if we take cosine of that theta here, cosine of the theta will be A, you see that one? Adjacent over the magnitude of the u. So if you cross multiply, you get A equals the magnitude of u, the vector itself, times the cosine of the theta. So it goes here. That's the horizontal component. And then sine theta will be the opposite, B over the magnitude of u. When you cross multiply, you get B magnitude of u sine theta. So what you have to remember is this very important formula. Vector u has AB as components. Always it will be the magnitude of the vector itself times the cosine of the theta, the direction angle. And then the other component will be the magnitude of the u times the sine of the theta, direction angle of that vector. Now this is an important question. It might come in many other questions. Find the horizontal and the vertical components of the vector v with magnitude 8, direction angle 2 pi over 3. Now, if you look at this question, the magnitude is 8, that's easy. Direction angle 2 pi over 3. Which quadrant is 2 pi over 3? For sure, you will say quadrant 2. Now, let's put the formula here. Vector v, the magnitude of the V cosine of theta, magnitude of the V sine of theta. So we can put here 8 cosine 2 pi over 3, 8 times sine pi, 2 pi over 3. This is in quadrant 2, so we can expect here a minus, and here we can expect a plus. Now 2 pi over 3, you have to find the reference angle, pi over 3, and the cosine will be negative because it is in quadrant 2, so that's minus half, and this one will be square root of 3 over 2. When you multiply by 8, you get the vector V minus 4, 4 square root of 3. Vector operations, we have two vectors, u and v. U is a1, a2, and v is b1, b2. We can add the vectors. See, these are the operations here. We can do operations. We can add the vectors, that's addition. We can subtract the vectors. So when you add them, you add the components. And then when you subtract also the components. Or we can multiply by a scalar. Scalar means a real number. C belongs to a real number. So CU, we multiply C, it can be positive or negative, times du. So it will be CA1, CA2. And then we can multiply also by minus 1, minus u. This is the opposite of the vector in the other direction. So it will be minus a1 minus a2. Let's see this one here. Given the vectors u and v, so easy question. Find the following vectors. U plus v we have to find. Minus 2u we have to find. 3u minus 2v. So we multiply the vector u by 3, and then we can multiply the vector v by minus 2, then we add, or multiply the vector v by 2, then we subtract. Now, if we look at the solution of example 5, given the vectors u and v, I wrote them here again. So u plus v, just add minus 2 and 4, you get 2, 1 and 3, you get 4, so that will be 2, 4. Minus 2u, just multiply the vector u by minus 2, so we get 4 and minus 2. Here we have to do some work. 3u, so I multiply 3 times the vector u, minus 2, 1. Minus 2, multiply the vector v is 4, 3. So here becomes minus 6 and 3. Here I can include here as minus 2 inside, and then I will add to make it easy. So I can take minus 2 times 4, minus 8, minus 6. Then when I add, I get minus 14, minus 3 is the vector. Now this is an important, because you have to do some fractions there. Given the vectors u and v, minus 2, 1, minus 4, 3. Find the magnitude of the vector 1 over 3 v minus half u. So first, we have to find this vector. Then we find its magnitude. So this is the given here. Remember here, v is the second vector in the given. And here we have in the question 1 over 3v. Let me go back and show you here, please. This is 1 over 3v. Many people will take the first vector here and put it there. You see, that's a little trick. So 1/3 v, take the second vector v. Just be careful, please. So 1 over 3, 1/3 minus 4, 3, the vector v minus half, the vector u minus 2 and 1. So you multiply this, you can take a minute here, please. I put here some question mark. You can just take a minute, please, to try it. Find the vector itself, and then find the magnitude. You can see the solution and the answer on the next slide. Ready? Let's go. Now, minus 4 over 3, 1, and then 1 minus half. When you add minus 4 over 3 and 1, you get minus 1/3. 1 minus half is half. Now this is the vector here. Let's find the magnitude. Remember, magnitude, we put 2 bars. We don't call them absolute value. We call them mag or magnitude. Square root of a squared plus b squared. So minus 1 over 3 squared and 1 over 2 squared. When you simplify all this, you can do it, please, and try it. Square root of 13 divided by 6. Please try it yourself and check the answer. This is another important question. If the magnitude is given, it's a very nice question also. The magnitude of the vector t is square root of 202. And the vector t, capital T itself is 2k minus 1, 2k plus 1. So if the magnitude of this vector is this is the magnitude. Find the product of all values of the k. So you might get 1k, 2k's, 3k's, whatever. Find the product. So let's find the magnitude of the vector t by the formula. The magnitude formula is magnitude of any vector u, that's a formula here, yellow, square root of a squared plus b squared. Now, the magnitude of the t will be the square root of the first component here, 2k minus 1 squared plus 2k plus 1 squared. Now just expand using these formulas from the algebra. A minus b all squared. So this is like 2k minus 1. 2k is the a, 1 is the b. And we have here squared with the minus, here we have squared with the plus. So I put here for you two formulas. The only difference is either the minus or the plus. So it will be this 4k squared minus 2ab minus 4k plus 1. And the second one we get 4k squared plus 4k plus 1. Now we can cancel the 4k with minus 4k, we cancel. We can add here 8k squared plus 2 is equal to square root of 202 from the given. Now we square both sides for sure, and then rearrange the equation, find the k's. So when you square both sides, you get 8k squared plus 2 is equal to 202. Take 2 on the other side, 8k squared is equal to 200. Divide by 8, k squared will be 25. So there are two values for the k, plus or minus 5. When you multiply them, you get minus 25. Now, what is a unit vector? See, from the word, we can understand. A unit vector, by definition, is a vector with magnitude 1. We have two special unit vectors. See, we can write here the vector I and the vector j. The vector I is the components 1, 0. That's fixed here, the special unit vector. And vector j, 0, 1. So this is a vector and this is a vector. Now, any vector can be expressed, can be written using I and j. So if we have a vector v, ab, then we can write v as ai plus bj. Or this example here, put two examples actually. Vector u, 3, 4. So you can write it 3i plus 4j. You can go back also and write the vector 3, 4. If you have this 3, 4, you can go here. If you have 3i plus 4j, you can go back and write the vector. The same for minus square root of vector w here, minus square root of 3, 1. So we can write minus square root of 3i. Remember, I is outside the square root plus j. So this is a way to express the vectors using I and j. Now here is a unit vector in the same direction. See the first one here, in the same direction or the opposite direction of a vector. So if you have any vector in any quadrant, in any place, you can find a unit vector, small vector of magnitude 1 in the same direction. Look at the formula here. Suppose here we have a vector u. See, this is a vector uab. I need a unit vector. Just take the vector u and divide that by the magnitude of the u. Now the vector u is ab. We know that there are two components. And the magnitude of u is a number. And we know that number, which is square root of a squared plus b squared. So this is like a scalar. So when you multiply 1 over the magnitude here, it will be a over this magnitude, comma, b over this. This is a vector now. See, this is a big vector, but it is a unit. Unit means if you find the magnitude of this, it will be 1. And also in the same direction, same signs of the vector u. Now, if you need a unit vector down here, in the opposite direction. Just multiply with minus and take the same formula there. So it will be minus u over the magnitude of the u minus AB over the magnitude of u. So when you multiply that scalar, you get minus A over this magnitude, comma, minus B over this. So this is, what is this now? This is a unit vector in the opposite direction of u. Let's see a nice example, I think here, yes. Find a unit vector in the opposite direction of the vector v, minus 2i plus 3j. So the vector v is minus 2i plus 3j. We can write the vector as minus 2, 3. The components are there. Let's call the vector w the unit vector, the small vector of magnitude 1 in the opposite direction of the v. So this is the v and this is the w. So now the unit vector, which is w, now we need minus v because it's the opposite, divided by the magnitude of the v. We can find first the magnitude of the v, square root of a squared plus b squared. So minus 2 squared is 4, 3 squared is 9. That will be square root of 13. Now the opposite, we multiply minus times the minus becomes here 2. Minus with the 3 becomes minus 3. So now the w, which is the required, the unit vector in the opposite direction, will be 2 over square root of 13 minus 3 over square root of 13. Or we can write it in another form. We can write 2i over square root of 13 minus 3j over square root of 13. See, that's the same answer, but different form. Another form also, we can take I, we can write it here on the line. 2 over square root of 13i minus 3 over square root of 13j. So all these are different forms. Now these are some old exams questions. Number 1, given the vectors E and F, find the magnitude of the vector half E minus 3F plus 2J minus 3I. So the idea here is find all this big vector and then find its magnitude. Question number 2, given a vector v with magnitude of v is equal to 4 and the direction angle is 7 pi over 6. Find a unit vector in the same direction of v plus 5j plus square root of 3i. Now, question number 3, given the vectors e, 6 minus 4, and vector f, 1, 1, find the direction angle of the vector half e minus 3f plus 2j minus 3i. First, you have to find all this vector here, the big vector, and then you find its direction angle. Question number 4, we have the vectors given v minus square root of 3, square root of 3 minus 1, and the vector u with magnitude 6 and the direction angle 5 pi over 3. Now, if mn is a unit vector in the opposite direction of the vector h, find m plus n. That's a multiple choice question, A, B, C, D, E. So the idea here, you have to establish or create or find the vector h, which is u over 3 minus square root of 3v. First, you have to find the components of the vector u. Then divide by 3 minus square root of 3v, you find h. Then you find the unit vector in the opposite direction of h. It will be mn. Question number 5, if k is a vector of magnitude square root of 3, that's given, then find the sum of the horizontal and the vertical components of the vector 4k, whose direction angle is 15 degrees. So the direction angle of 4k is 15 degrees. Right? This is a nice question. Now here are the answers for the 5 questions. For complete solutions, please, you can see the video on vectors in 2 dimensions, lecture number 27, pre-calculus, old exams questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is Pre-Calculus course, lecture number 27. I hope I can see you in another video with another topic. Thank you for listening. Bye.